Hey Conservancy kids, welcome back. It's Nicole again, and today we are going to do our first exploration together that we're going to use our science notebooks for. As you guys can see, I spent a little time the other day designing the cover of my science notebook to make it a little more personal. I hope you guys had the same opportunity. I also went through and I finished numbering all of my pages so that I can use it to record in our table of contents. You'll see on the table of contents, I added a place for the title of any exploration or experiment that we do and the page number that it starts on. So we will fill that out, the first one, at the end of today. So we are doing our first exploration about how water moves over different surfaces. So to start it off, I'm going to turn to a new page in my science notebook. I've already taken the time to fill this out, but go ahead and do it in yours. So what I did is I wrote a title. I just called it Water Movement. I included the date that I'm doing this and a really short description about what this exploration is all about. Something that'll jog my memory when I look back over my notes. I just said that it's an investigation of how water moves on different surfaces. Pretty easy and straightforward. I also have my materials. So first and foremost, I laid out a towel because I'm working on my mom's dining room table and I don't think she would be very happy if I got water on it. So I put down a towel, I put down a cookie sheet that will help capture any puddles of water depending on how crazy I get. I have 3 different materials. I have tin foil, I have some wax paper, and I have a paper towel. Now the types of materials that you use and you investigate how water moves on them, it doesn't really matter. So if you don't have wax paper, go ahead and use just a regular sheet of paper. Or maybe you have some fabric laying around the house. It doesn't really matter what the materials are as long as you have different materials to explore and observe. What else do I have? I also have some different tools to get water on these materials with. So I have a spray bottle. I have this kind of pipette thing that I found in my medicine cabinet. I have a plastic straw that actually works really well as a pipette. So if you put it in a glass of water and then you stick your thumb over it, you'll notice that it keeps some water inside. And the easiest thing, a cup of water and your fingers that you can just flick some water on the different materials. I also have a brick that I found in the backyard. I'm going to use this to help create different angles of the materials. So I can try putting water on a paper towel when it's flat like this, but then I can also put water on the paper towel when it's at a little more of a slope, or it kind of creates a mountain. You don't need a brick, you can use a rock, you could use a plastic Tupperware, really anything that's going to help you create some elevation and some angle to your different materials that you don't mind getting wet. So I'm just kind of going to get started. There's really no rules to this exploration, it's just pursuing what I see and any questions that come up. I'm going to try the tin foil. And I'm going to spray some water with my spray bottle on there. So the water kind of disappeared on here. There's some droplets that are coming off the edge, but it didn't really do a whole lot. It definitely didn't absorb. So I'm going to try it on like a low slope and see what happens. So I'm going to wipe it. That's another great thing about this towel is you can kind of wipe off your surfaces a little bit. So I'm going to do a little bit of a slope, and this time I'm actually going to try with my pipette. So let's see what happens. So the water ran right off, and that actually brought up a question for me because I tried it when the tin foil was flat, and I tried it when it was at a slight angle. But I'm wondering, I can also make this an even bigger mountain. Look at that. So I can test how water moves differently depending on how steep that slope is, whether it's up really far, so like a really pointy mountain, or a little more gradual, so maybe it's more of a hill. So that's a question that I have that I'm going to write down in my science notebook, and then I'm going to record what kind of observations I see. Now, at this point, I want you guys to explore all of the different materials. Go ahead and ask questions, write down your observations about how water moves over these 3 different surfaces, or 4 or 5, however many you want to test out at home. And then you can pause this video, and then when you're done, come back. So hopefully you guys have had time now to do some investigating into these 3 different materials that we're putting water on. And now you have all these observations that you've written in your science notebook. We are going to create a claims based on evidence T-chart. And that sounds really fancy, but it's actually really easy. So I've already created it in mine. You'll see that on this side, I have evidence. And on this side, I have claims. So evidence is anything that we observe. It's facts that we use to help support a claim. And a claim is a statement about something that we believe to be true that we back up with evidence. So all of the observations that you've made in your science notebook, those are all evidence. And so now we're going to try to take that and make claims about how water moves in the natural world. So I was saying that I noticed that the tin foil, water seemed to move off of it faster the steeper the slope was. So that would be my evidence. When I put water on tin foil, the water moved off the tin foil faster when the slope was greater. The claim I can make of that, if I think about how that would relate to the natural world, is I can say water runs off mountains that are steeper than it does over more gradual, less steep hills. So go ahead and go through all of the observations that you made in your science notebook. Write down the claims you can make based on that evidence about how water moves over different surfaces in the real world. And then I encourage you guys to go outside and test those claims. So maybe you noticed a difference between some of your materials being permeable, meaning water can move through it, versus impermeable, meaning water can't move through it. Well, go ahead and go outside and test that and see what materials, what surfaces in nature are permeable versus impermeable. It's a great day for exploration. The awesome thing about science is that there are no wrong answers. It's all about modifying our initial thoughts as we gather more observations and more evidence. So thank you for joining me, scientists. We look forward to seeing you again.